It's the year 2026, and if you listen to Tech Twitter or read Hacker News, you would think that the only two ways to write software right now are either asking an AI agent to do it for you or rewriting your entire codebase in Rust for memory safety. And look, I get it. Rust is an incredible language, but despite the massive hype, I'm spending this entire year going deep into modern C++. Hey, I'm Thomas, and over the last 6 years, I've worked on everything from React frontends for banking applications to multi-device IoT factory controllers, desktop applications, and writing raw, performance-intensive C from scratch. But right now, I'm pivoting my career into one of the most ruthless, highest paying, and technically demanding subfields in computer science: quantitative finance and high-frequency trading. In normal web dev, which I've done a lot of, if your API takes 50 milliseconds to respond, nobody cares. The user blinks, React DOM updates, and life goes on. However, in high-frequency trading, if your matching engine takes 15 microseconds to execute a trade, you didn't just write a slow program. You are literally ages behind your competition and losing money. Just so we're on the same boat, we are talking about an industry that literally shoots lasers and microwaves from mountains just to shave fractions of milliseconds off of network latency. You cannot afford the unpredictable latency spikes of garbage collector pausing your program to clean up memory, which instantly rules out languages like Golang, C#, or even Java. You need absolute control over the hardware and cache lines. Now, since I've built systems in pure C before, a lot of people might ask, if you want raw hardware control and zero overhead, why not just write the exchange or algorithms or simulations in pure C? The reality is, modern C++ can actually be faster than C. It all comes down to zero cost abstractions and how the compiler handles them. Take a simple sorting algorithm. In C, if you use qsort, you have to pass in a function pointer for the comparison logic. That means for every single item it sorts, the CPU has to make a function call, jumping to a different part of a memory. This absolutely destroys your instruction cache and branch predictions. On the other hand, in C++, stdsort uses templates. The compiler knows the exact type at compile time and can inline the comparison function entirely. There is no function call overhead. In a world where every nanosecond counts, the C++ compiler's ability to optimize templated code makes it the superior choice over pure C. So, we've ruled out garbage collection and we've ruled out pure C. This brings us back to the elephant in the room. Why not Zig or Rust? They are the absolute favorites of modern systems programming right now. Let's start with Zig. I actually love Zig's explicit memory allocators, but it is simply too new. When your software executes hundreds of millions of dollars in trades every single day, you do not bet your firm's existence on a language that still has breaking compiler changes. And Rust? I actually really like this language. It introduced me to systems level and embedded programming. It also introduced me to some performance optimization concepts. Rust is actually beginning to be slowly and surely implemented in this field, but mostly for risk management systems, tooling, or crypto exchanges. However, for the ultra low latency critical paths, the core matching engine is still written in C++. And C++ actually has some qualities that make it more suitable for writing the core matching engine. First, the ecosystem. Hardware vendors for low latency network cards provide highly tuned C++ APIs. Trying to build FFI wrappers for Rust just adds friction where you want zero development overhead. Second, to squeeze out the absolute last nanosecond of performance in Rust, you often have to bypass its borrow checker rules and write unsafe blocks anyways. And once you're writing unsafe memory manipulations, you lose Rust's biggest selling point, and you might just as well use C++, which has decades of better tooling for making sure that your memory manipulation operations are correct. And the third edge C++ has over Rust is that it's more easy to control your memory layout and managing your memory in general. Beyond just the performance, there is a massive career strategy behind learning C++ in 2026. People treat C++ like it's a legacy language, but it powers the entire modern AI boom. CUDA, PyTorch backends, browser engines, autonomous vehicles. They all run on modern C++. But in finance, the advantage is even deeper. The engineers who built the core trading systems over the last 2 decades are gonna slowly but surely retire. And no other programming language ecosystem has the 30-year history of C++. These libraries are specialized, highly optimized, and battle tested. I believe that the demand for developers who can read, maintain, and extend these code bases is going to skyrocket. And just to be on the same note, I'm not starting completely from scratch. I'm comfortable with writing low level embedded software, for example, utilizing Zephyr OS or Arduino or Platformio. I've also written some code that interacts with the system APIs. Also, I'm kind of familiar with Linux. Right now, I'm using macOS, but I was using Arch for like 2.5 years, so I've got some experience there. But getting into Quant requires a completely different skill set. You have to master algorithms, system design, you have to grind lead code, and this is exactly what this channel is gonna be about. I'm not just going to read C++ documentation or effective C++. Over the next few months or decades, I'll try to build a high performance algorithmic matching exchange from scratch and post some optimization videos slash lead code problems or anything that is under the optimization slash C++ umbrella. For example, this also covers zero allocation data structures, log-free queues, kernel bypasses, and much more. I'll be documenting everything I'll learn along the way and also my preparation for quant interviews. If you're a software engineer looking to level up your systems knowledge or just curious about everything I just mentioned, hit subscribe and I'll see you next week or whenever the next video comes out. Okay, see you.